Hi, this is an example, the first example with MODELMUSE, please. And first, you need to open your MODELMUSE. We are going to set up a very simple model, right? And then if you install the MODELMUSE, you can open MODELMUSE. And then after that, we are going to set up a simple model, okay? Um, uh, let me first explain you here what kind of the model we are going to use in this case, okay? We are going to use this example. You have here, for example, this is the conceptual model, right? This model has two layers, and then the first layer, the thickness is 12 meters, and the second one is 5 meters, okay? The top of the model, the elevation is 10 meters, okay? We are going to see in MODELMUSE. And then you see here, for example, this is the view plant here, and then you see the extension here of the model is 1,000 meters, is 1 kilometer by 1 kilometer, right? And the flow is coming from the east to the west, okay? And we have the constant head boundary there, it's 10 meters, and the second one here this is in the east. In the west, we have the h equal to 8 meters, okay? 8 meters. Of course, we don't have flow from this in the north and the south. We don't have, okay, flow in this case, okay. Look at this. This is the main hydraulic conductivity here for the first layer. In this case, this is the value that we have is around the 42 meters per day. In this case, we have in second, and then we assume here that Ky, the horizontal in this case is equal to the lateral hydraulic conductivity. Ky is equal to Kx. And we don't know in this case the vertical conductivity, in this case Kz, we are assume, in this case we assume that is equal to 1/10 of the Kx in this case. And the porosity in this case is 0.27, okay? I'm sorry, 0.25, okay? The second layer, the one is about 60 meters per day that you have here. You see the value. And the same, the lateral hydraulic conductivity is equal to the horizontal hydraulic conductivity, and the vertical conductivity is 1/10 of the horizontal conductivity, and the porosity is equal to 0.25, okay? And then, okay, let's start with MODELMUSE. First, you need to create the new, in this case, the new MODFLOW, okay? New MODFLOW model, okay. New MODFLOW model here, click, and after the next, okay? And then don't worry about this, and then you can change it after that. In this case, we are working, we are going to work in meters, in seconds, and then after that you can change for the your time step. You can change in hours or days, years, okay? Okay, next, and you can select here in this part. For example, you see, you can select MODFLOW 6 is the last version, on MODFLOW 2005, and then MODFLOW NWT, and other MODFLOW versions, okay? We are going to start with this MODFLOW 6, and then, you know, here, this 1,000 meters, or 1 kilometer by kilometer, we are going to discretize by 20, in this case, 20 columns and 20 routes. And of course, here, the column width will be 50 meters, okay? And the row, of course, the row width will be 50 meters, okay? And then we are going to work in this case. Actually, in the classroom, I was explaining to you that with one layer. I'm going to include one more. And then the top, look at this. This is the example. This is the top, will be 10 meters. And then we are going to put there 10 meters. And then this one, the upper aquifer, the second layer here will be -2, right? Because the thickness is 12 meters for the first layer, okay? And of course, for the first layer is unconfined layer, and the second one is confine layers, okay? Here will be -2, okay, -2, and the bottom here in the second layer will be -7, okay, -7, okay? And then we know in this case the thickness of the second layer is 5 meters, okay? That's all, okay? And to layers, if you know, for example, the coordinates here you can put, in this case, we don't need to add the coordinates here, and of course, X, Y, Z, or you can add here the grid angle, okay, in degrees. And the vertical exaggeration that we can see this one in MODELMUSE. After that, you can click here, finish, okay, and then you are gonna see this, okay. There is a message here, a new version of MODELMUSE is now available. Close. After that, you can, of course, update the model, okay. And then you are gonna see this, okay, this screen, and then you can move using this hand to move your area that you are gonna work with these two layers, this simple model, okay? And the idea here is to find, the objective is to find the contour, groundwater contours, for example, okay? Okay, the first step that we need to do is to configure, for example, the 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 data, okay? And then, but it's very interesting that you can click here, select two objects, and then to see in the bottom, and then you can see here, for example, the two layers, right? That one is the top stem, this one is -2, and this one is -7, okay? That one is the two layers that we have. And on the right, you see the lateral view here, for example, right? You see the lateral view, and then in the bottom, on the right, you can see in 3 dimension the model. You can move, okay, you can see. We don't have anything now, okay? And then the first step to configure, to set up the model, the groundwater model using MODFLOW, because remember, the MODELMUSE is the interface for groundwater models, okay? MODELMUSE is not MODFLOW, eh? MODELMUSE is a graphical interface, okay, for MODFLOW in this case, okay. These are free from is free, of course, from US. Here about, you can see more. You have more information here. You go to click here and help, and then you can see about. Click, and then you see this model is from USGS, okay, USGS, okay. This is very strong free use of graphical interface, okay, that you can use. Okay, this is the version that I have is 5.2. Okay, close. First, that you need to first go to here, data, and then edit data set, because you need to configure the hydraulic conductivity. In this case, we are going to work this will be for the first layer will be this value, right? But per second, okay, per second. And what is the meaning here? And then it will have 5. This will be 0.0005, right, meters per second. And then we can convert, because we are going to work in days, okay, the time step, or we can use this, okay, the same value, okay, the same value. And then I'm sorry, the time step we can use seconds, okay, the seconds, okay, if you want. So, and then will be on 0 point, let me configure it here. It will be 0 point, in this case will be 0, 1 0 more, okay, 5, okay. That one will be the horizontal hydraulic conductivity. And then, of course, we assume in this case that lateral hydraulic conductivity is the same, and then the KZ, the vertical, will be 1, or the default will be the horizontal hydraulic conductivity over 10, okay? And then, okay, that's all. But the problem here, and then we can verify the top, for example, of the system is 10, and the top, or in this case, the upper aquifer, the second layer is -2, and the bottom, the second layer is -7, okay? And the question here is, but what's happened with the second layer? There is three ways to configure it, to set up the hydraulic conductivity for the second layer. Okay. For example, one of them is to we are going to close to here, for example, and then we can add here, for example, this object here, and then to put, for example, here, the whole, we are going to configure here. For example, I can put hydraulic K second layer, layer 2, for example, okay, layer 2, and then we can say here, we can set up here from the model top. No, this one will be from let me see here. Or we can use from, let me see, I'm gonna change this, will be from the, let me see, I'm gonna verify this, cancel here. Let me verify here, please. I'm gonna make sure this one, and the second layer, yes, upper aquifer water, okay? That one is, we need to use upper aquifer water, okay? And then you need to set up from the upper, in this case, upper aquifer, okay? Bottom, okay? Okay, that's all. Okay, let me see. Okay, and then once again, I'm gonna add this object. Okay, 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 and then we can set up here from the, here will be from the upper, right? Upper aquifer thickness, aquifer bottom, okay? Aquifer, aquifer, in this case will be the bottom, okay, the bottom, okay? Okay, yeah, okay. Okay, we can set up here, for example, hydraulic conductivity. We're going to use the 3, and then the first one will be, the value for this one will be around 2. Okay, 0.00. Okay, this is 0. Okay, we need to, there is a 0.008, right? And then go back to our model, and then here will be 0.08, okay, meters per second, okay, 0.0008 meters per second, okay. Okay, the lateral hydraulic conductivity is the same. The horizontal and the vertical is 1/10. Okay, we know that. Okay, once again, we need to put here will be hydraulic conductivity. I'm going to put the name here for layer 2. Okay, layer 2. Okay, excellent. And then, okay, we define this. If you want to put your changing the colors here, if you want. Okay, that's all. That one we need to in this case. Okay, and then after that we need to correct here the value, edit data set, and then go for the first layer, first layer in this case, and then we assume this one was in this case was 0.4, right? And we're gonna see here 0. Okay, 0.005. Okay, then 0.005 here. Okay, meters per second. Okay, so okay, apply and then close. We are gonna verify in this case the second layer. Okay, second layer, and then we have 0.08. Okay, we assign to. Okay, okay. If you wanna see the changes here about your hydraulic conductivity, we are gonna go to here and then data visualization, click, and then you go to for example, let me see. Uh, you can go to here and then to see, for example, let me see the hydraulic conductivity, for example, okay? And then, okay, you see one value here, and then you are not seeing the, and let me see, and then you have only, and there is a mistake here for the hydraulic conductivity. This is only one. And then let me explain, let me see what's happening here, okay? And then to fix this, because another method that we have, we need to once again to put here apply and then close, and then we are gonna go to we are gonna to let me see here the object, click here in object and then go to show or hide the object. We are gonna here uh, hide the object and close, and then once again another procedure that you have to set up the hydraulic conductivity is go to edit data set, go to click there, and then go to hydraulic conductivity, and that edit formula, and then after edit formula, you can go to data set, and then require, and go to, or you can use functions, right? Logicals here, and the case, for example, case. And then case index here, you can put, for example, the layer, and then you put your values here, okay? For the first layer, for example, we can put, for example, the, let me see, the value will be, let me see the value for the first, that will be, let me see, wait a minute. Yeah, that for the first one will be 0.0005, okay? Okay, here will be 0.0005. For the second one, we can set up here 0.0008, okay? That's all, we don't have another one. We can set up another one, for example, and then we can close this, okay? That's all. And then we can say, okay, and then apply, and then close, okay? Now we can go to data visualization here, and then color grid, and then we can go to data setup, and then hydrology, and then K, and we can select here, for example, and then we can apply. Now you can see, for example, here, the two, for example, values. If you are gonna look at this in the bottom, right? The profile of the two layers, for example, you can see here, okay? And the first one has 0.005, and the second layer has here, you can see here, okay? You can see here, zero for the first one, 0.005, and then for the second layer, you have 0.0008, okay, meters per second, okay? Then now you have the two layers has, in this case, have the hydraulic conductivity. The next is, now once again, go to uh, data visualization, and then go to color grid and select no one, apply, and then now you have your once again your model this this way, for example, okay? And then we are going to set up the boundary condition in this case, okay? We have two boundary conditions here, the east boundary condition, and then I'm going to use this rectangle, and then here click, and then click the upper top on the right, the cell, and then you can, like here will be the boundary conditions. This will be is, okay? Is, and then this is the total from model top to upper aquifer. will be to total, right, to the bottom. In this case will be, let me see, okay, that will model top to the bottom, right? That we need to set up here, the bottom, okay? Let me make sure about this name, and then you can see, okay, that one will be upper aquifer bottom, model top, middle aquifer bottom, okay? This one will be here for the total in this case, okay? And then once again, to set up the boundary, this will be middle, right? This will be middle, okay? And then we are gonna, once again, the one will be, this one will be the is boundary condition is, okay? So you can put here colors, and then to change it to the blue, the same click, and then yeah, let me see. Okay, here we are gonna select, of course, the boundary condition after that, but first we need to put the objects, okay? Okay, click, and then you are gonna have the same for the west boundary condition. Click, this one will be boundary condition, and this one the west, okay? And this is model top and the middle, okay? Middle and bottom, aquifer bottom. We can put the colors here, and the interior color, that's all. Remember, model up to middle aquifer bottom in this case, and then data set, and then you need to select for both hydraulic conductivity. We are going to use the same hydraulic conductivity, okay? That's all. Active here, don't forget. That's all, okay? We are going to once again to verify this one, and then data set to select the active, and then K, hydraulic conductivities, close, okay? For the general data, go to data, edit data set, click, and then active need to be true. Hydraulic conductivity, we have now the function now for the two layers. If you have three layers, you can put here the number 3, for example, okay? For the number 3 layer, for example, or layer 3 you want, for example, you have, for example, okay? Okay, apply, and that's all. Now we need to set up the boundary condition with values, okay? We need to select what kind of the boundary conditions we are going to use. In this case, you need to go to model here, click on model, go to MODELMUSE package and programs, and click, and then after that you are going to select. There are many boundary conditions. I'm going to explain in the next videos, in the next classes, of course, and then go to boundary condition. First of all, here flow package, and then I'm going to explain later about this. And then we have many flow package. In this case, we are going to select the no property flow package, okay? And then I can explain to you later, okay? Later. The boundary conditions, and then you have here a specific head and a specific flux, and the head depend on the fluxes, okay? In this case, we can select this in general head boundary here. Or if you have, for example, if you wanna specify the head in your boundary conditions, you can, of course, use this CHD. This is the CHD boundary condition. This is the time variant changing with the specific time. But we are going to use now the steady flow conditions or stationary conditions, and then we are going to select this general head boundary condition. Okay, I'm going to explain in class, of course, the equation of this, of how it's going to work this general head boundary condition. Okay, close. Okay, that's it. And then now, and then go to click in your boundary condition here in your object, and is boundary conditions. Click and go to MODFLOW features here, MODFLOW features, and select, in this case, your boundary condition, GHB, and then after that, select here. One, this is for the default, and then close. Once again, we need to see here first to, in model, go to MODFLOW time. The MODFLOW times, you need to make sure that you are working first in the steady state. And then, of course, you can change this. You are simulating, for example, transient conditions, for example. In this case, we are going to start with the steady flow. I can change it as 0, -1, for example, here, okay? Or -1 to 0, in this case. The length is 1 second in this case. Or I can change, if I change it here, the time step, you need to convert your hydraulic conductivity, okay? You need to put, in this case, in the days or meters per day, okay? Meters per day, okay? And then, okay, close here. After that, once again, click in your boundary condition, is boundary condition, and then go to MODFLOW features, and then select to your GHB and general head boundary conditions. And then after that, you are gonna here select to the time, okay? It's 1 second. And then you can select here to your boundary head, for example. Here it's according to our problem, it's 10 meters, okay? 10 meters, you see here. Conceptual model here is 10 meters. Okay, here is very important to understand the conductance that we need to calculate. I was explaining in class the conductance, right? This is a function of the hydraulic conductivity of the area and the length, in this case of the area. We're gonna assume here, for example, around the 100, okay, 90. In this case, 90, sorry, 90 is the value. And then we can calculate, of course, this one. Do you remember when we were talking about the interaction in between the river and the aquifer? We were talking about the conductance, okay? And let's assume this value, okay, 90. Although this is a very, if we consider, for example, let me try to do some calculations for this, okay? Let me try. Wait a minute, please. Wait a minute. Okay. Okay. We are gonna change this value. This we need to put the conductance here. The conductance here, it will be equal to, do you remember when we were talking about the conductance for the interaction between the river and the aquifer, and the conductance in this case for general, for this boundary condition, the general head boundary is equal to the transmissivity times the width of the cells, in this case, over the length of the system. In this case, the porous media, we are working, for example, for some control value, or for some, for example, prints, for example, in the porous media. In this case, I'm going to explain you in class this one. And we can assume here, because we are working in the, we can assume here, we are working in the time stamp will be in seconds, and then we can, if we find the transmissivity for our model, in this case will be, for example, we can have the average, or and you know now to find, for example, the average hydraulic conductivity, for example, and then to find the transmissivity, this will be the thickness times the hydraulic conductivity, okay? And then in this case, we are going to assume, in this case, we are working in the in seconds, the time steps, and then we are going to have 0. Let me see. Will be 0.065, for example. Okay. So no. continue records. Okay. I'm so sorry. I don't know if we have if you hear me. Okay. I explained you. I was sorry. Let me see. I don't know what's happened here. And let me find here. Okay. And then I was explaining you that we need to change this value. We are going to assume this because we are working in seconds. The time step in this case is in seconds, and then we need to change it here 0.00. And the conductance in this case is the transmissibility times or multiplied by the width of the cell, for example, over in this case the length. Okay, in meters. Of course, this one will be very important to in order to use this general head boundary condition. Okay, and then that's all. And then okay, okay, and then the next one, and we are gonna change it here in the west boundary condition once again to select, in this case, the boundary conditions, and then once again to calculate here, and then this is the ending time, and then here we are gonna, according our model, it's 8 meters, okay? 8 meters, okay? 8 meters, and then that's all, and then here the same conductance, okay? 0, 0, 65, okay? Same conductance. And then we can say here directly, for example, yeah, directly, yeah, directly. We are gonna change here directly, okay? Okay, close. And then once again here, we are gonna go to here, and then we are gonna change here directly, okay? And then after that, we can adjust this value, for example, okay? That's all. And then now we can run the model. Click here, run the model, and then to put, for example, try to generate the, I'm gonna select here, I have MODELMUSE examples and the folder, and then I'm gonna put, for example, here, I'm gonna put, let me see here first, okay? I'm gonna create another one here, and let me see, one second, and then I'm gonna create here MODELMUSE examples 2, okay? Here, and then here I'm gonna put the name MODEL1, for example, okay? Save. And then, of course, then I told you that we need to, for example, set up, in this case, MODFLOW. Okay, we need to download MODFLOW. I don't know if I have now MODFLOW 6 here. And I download, let me try to see here in software. Let me see in software. I don't have, actually. I need to download here the click to download MODFLOW 6. The execute file, okay? On here, download on the current version, MODFLOW 6, and then go to here, click, then you are gonna download, okay? Wait a minute, please. While the model is downloading, we are now downloading the model, and let me see to put the equation of the conductance, okay? And then put here, and the equation here, the is equal to conductance is equal to here. The one is the transmissivity times the width over the R, okay? The R, okay? That one is that way we can calculate the conductance in this case, okay? Conductance, okay? Okay, let me put here. That one will be the conductance, okay? Okay, and let me see here. Wait a minute. or will be the conductance, okay? Conductance. Conductance, okay? Okay? T, once again, it's the transmissivity, and W is the width in meters, and transmissivity, we know, square meters per second or square meters per day, okay? Because the transmissivity, you know, is the hydraulic conductivity times the thickness, okay? You know that, okay? And then L is the length in meters, okay? We are gonna see how is going on the executed file now. Wait a minute, please. Uh, okay, now I download the MODELMUSE 6, please, and then uh, let's see in software. I have here this folder, and then look at this. You need to unzip when you download this one. This is the MODELMUSE 6. You need to unzip this file, and then after that you are going to have this. Okay, and the executed file, it's you need to click here, go to bin, in this case bin, and then you need to select here. This is the MODELMUSE 6, the executed file. Okay, and then go to once again to our model, and then click here and this folder, click, and then try to select your MODELMUSE 6. Okay, go to software. You can put in any folder, okay? In any folder. I'm gonna choose this MODELMUSE 6, click, and then click here, and then after that to select this MF6, this one. Click. Okay, now you can run the model. Okay, that's all. If you have red here, red colors here, you need to review your model, okay? And then now I'm gonna close here and close, and then you are, for default, you are gonna see this. Let me see, this one, this file, this LST file, okay? And then you can review this one to analyze the water balance, okay? And here you're gonna see the interactions, the row, okay, the boundary condition, the columns, and then let me see here, where is the balance here? Okay, let me see here. Once again, okay, the total here is in the difference. And then let me see, and then what's happening here in this file. I'm gonna close once again to this, and then click secure, and then after that we are gonna go to see, for example, the example that we run now, okay? And then go to, I have a MODELMUSE here, and this one is, we need to look for this file, this one, LST file, and you can open, you can use any, and then, okay, the property, I think there is a special, okay, now it's complete. Look at this, here is the budget, okay? The balance, the water balance, the budget. Here we have the inputs, okay? We have the outputs. Here, the outputs is very small, right? That we need to, of course, increase a little bit more the conductance in this case, okay? And let me see, this is the inputs and the outputs, and then we are looking for this percentage, or this percent of discrepancy will be equal to zero, okay? The idea is to get this one equal to zero, okay? Okay, let's see the results. Okay, you can go to here to import and display model results, click, and then you need to go your model. In this case, it's here in this folder, and then you need to select this file, BHD, okay? And then you have only one period, study flow, and then select this. Okay, you are gonna have this, okay? And then this is the you see here, look at in 3D. This is very interesting model, very simple model. And then we are gonna see the contours, okay? Click here in the data visualization, click, and then go to contours. We are gonna see, for example, the ish here, click in dataset optional, model results, 3D data, and once again, optional, model results, 3D data, and the head. Select to head. Here the contours we are going to see is 0.25, for example, 25. Okay, this is the interval. Okay, contour interval. Okay, and okay, I can put here 3 cycles, apply, and then you are going to see now the contours. Close, and then now you have the contours. Okay, the groundwater levels here, contours. Okay, the groundwater contours. Okay, you can go once again to data visualization, and then go to color grid, and then to select that one here, apply, let me see, apply, and then only you are gonna see here your contours. Okay, look at this. Okay, this is the first example. In the next videos, I am going to provide more knowledge about this, the modeling, groundwater modeling using, in this case, MODELMUSE, okay, the graphical interface, MODELMUSE graphical interface for MODFLOW in this case, okay.